Hello, welcome back to my channel. In this video, we'll learn about the data abstraction in Python. We will also learn about abstract classes. Check out some examples of data abstraction and we will find out why data abstraction is important. But before starting the video, if you are new here, please subscribe the channel and hit the bell icon to receive every new video updates. Also do check out other videos on my channel. I will attach link in description. Hold on, there are some prerequisites before learning abstraction. You must need to know the basics of inheritance. If you are not familiar with inheritance, I would recommend you to first watch my video on inheritance. Link is attached in description. Data abstraction in object-oriented programming. Abstraction is the concept of object-oriented programming that shows only essential attributes and hides unnecessary information. The main purpose of abstraction is hiding the unnecessary details from the users. Abstraction is selecting data from a larger pool to show only relevant details of the object to the user. It helps in reducing programming complexity and efforts. From a programmer's perspective, if we think about data abstraction, there is more to it than just hiding unnecessary information. One other way to think of abstraction is as synonymous with generalization. If, for instance, you wanted to create a program to multiply 8 times 7, you wouldn't build an application to only multiply those two numbers. Instead, you'd create a program capable of multiplying any two numbers. To put it another way, abstraction is a way of thinking about a function's specific use as separate from its more generalized purpose. Thinking this way lets you create flexible, scalable, and adaptable functions and programs. Abstract classes in Python. Abstract class are the classes that cannot be instantiated. This means that we cannot create objects of an abstract class, and these are only meant to be inherited. Then an object of the derived class is used to access the features of the base class. These are specifically defined to lay a foundation of other classes that exhibit common behavior or characteristics. The abstract class is an interface. Interfaces in object-oriented programming enable a class to inherit data and functions from a base class by extending it. In Python, we use the not implemented error to restrict the instantiation of a class. Any class having this error inside method definitions cannot be instantiated. We can understand that an abstract class just serves as a template for other classes by defining a list of methods that the classes must implement. To use such a class, we must derive them keeping in mind that we would either be using or overriding the features specified in that class. Let's take an example to understand abstract classes. Consider an example where we create an abstract class fruit. We derive two classes mango and orange from the fruit class that implement the methods defined in this class. Here the fruit class is the parent abstract class and the classes mango and apple become the sub-child classes. We won't be able to access the methods of the fruit class by simply creating an object. We will have to create the objects of the derived classes, mango and apple, to access the methods. Let us take some examples to understand the working of abstract classes in Python. Consider the animal parent class and other child classes derived from it. Our abstract base class has a concrete method sleep that will be the same for all the child classes. So, we do not define it as an abstract method, thus saving us from code repetition. On the other hand, the sounds that animals make are all different. For that purpose, we defined the sound method as an abstract method. We then implement it in all child classes. Now, when we instantiate the child class object, we can access both the concrete and the abstract methods. This will give the output as. Now, if we want to access the sound function of the base class itself, we can use the object of the child class, but we will have to invoke it through super. This will produce the output as. If we do not provide any implementation of an abstract method in the derived child class, an error is produced. Notice, even when we have given implementation of the sound method in the base class, not providing an implementation in the child class will produce an error. This will produce the error as in the snippet. Remember, had there been more than one abstract method in the base class, all of them are required to be implemented in the child classes, otherwise, an error is produced. Now that we know what data abstraction in Python is, we can also conclude how it is important. Data abstraction firstly saves a lot of our time as we do not have to repeat the code that may be the same for all the classes. Moreover, if there are any additional features, they can be easily added, thus improving flexibility. Not to mention, working in large teams becomes easier as one won't have to remember every function and the basic structure can be inherited without any confusions. Do you guys have any question in your mind? Do not hesitate to ask your queries in comment section. I will try to answer each of your queries. Stay tuned for more tech-related upcoming videos. Until the next time, goodbye.